Hi, my name is Alexander Limka, and this is a technical presentation on automated reasoning and machine learning. The learning objectives for this presentation is to gain some familiarity with the concepts of automated reasoning and machine learning, as well as understanding their place within the field of computing, and also understand the necessity behind these computing topics and other decision-based computing, as well as be able to spot some of this in everyday life and introduce some of the moral discussions held within the realm of decision-making software. What is automated reasoning? Automated reasoning is currently considered a subfield of artificial intelligence. However, it did come to rise before AI and is partially contributed to the paving the path of AI. Computer science, cognitive science, and mathematical logic are some of the areas with shared interests in automated reasoning. The goal of AR is to enable computers to reason completely or near completely automatically, oftentimes trying to imitate human reasoning. Automated reasoning uh, has subfields to it, such as automated theorem proving and automated proof checking, which are pretty common and kind of delve into their own differentiations of the field itself. So let's look at the origins of automated reasoning. Automated reasoning stemmed from developments that were made towards formal logic in the 1950s. And so the first AR program was called Logic Theorist, or LT, and it was created in 1956 by a team that consisted of Alan Newell, Cliff Shaw, and Herbert A. Simon. And so the goal of LT was to search a was to explore a search tree and prove a proposition. The root of the tree was the initial hypothesis, and each branch was a deduction based in the rules of logic. And so the main issue with computational proofs of that nature was they tended to grow exponentially. And so to reduce the search time, the team working on LT, they used rules of thumb or heuristics for their path selecting. And this was an aim to reduce the overall search time. And so the program itself, they had to create a new programming language to run their kind of theories here. It was called IPL. It's pretty similar to modern day Lisp in that it's a symbolic list processing software. And we have a quote here that kind of addresses how it was helping pave the way for artificial intelligence. Move on to machine learning here. So now from the birth and rise of computational reasoning comes machine learning. So machine learning is pretty self-explanatory. It's algorithms and programs that enable a machine to perform desired tasks without explicit instruction. Instead, the machine kind of relies on patterns and inferences to make selections. Within machine learning, there are different types of so you have supervised, unsupervised, and reinforcement learning, which are ways that the machine will learn and develop the data it's given, or also the ways to give data as well. It's also a subfield of artificial intelligence. Now, where AR and ML, machine learning, they're pretty similar. One advantage that machine learning has over AR is a higher degree of automation. It can be applied to low-level data, which can be given as sensory data from machines, whereas automatic reasoning is much more bounded by specific pre-designed scenarios that feature more complex logical problems. Automated reasoning tends to link data, whereas ML kind of takes in homogeneous data sets that kind of change. So we see machine learning as a subfield is kind of discussed here, and then deep learning is also derived within machine learning. Machine learning is a very important gear within the AI, within the realm of AI. So this is just a quick machine learning example. This is it's a video preference example. So we have the user preferences here. The bottom and the both axes represent random variables associated with the video, and we see there's clusters of positive represented by green and negative videos that the user has experienced. So what machine learning does is it kind of takes these clusters of positive and negatives, and when it receives a cluster, a new point, it kind of creates another cluster right there, observing other similar points near it. And so this cluster in the middle, this gray point, would probably be a negative. It wouldn't be shown to the user because it's more so closely bound with negative reviews or negative instances. Here we have some real-world applications. So the most common real-world application would probably be preference filtering. You also have simulation software development, and pretty much any machine using artificial intelligence is going to have machine learning within it. And so why is it important? It's important because it can improve the way people interact with computers and the ability for systems to evolve and develop based on data that they process. And some moral implications here is how far do we let computers make decisions? There's debate on, when computers are interacting with people, what kind of impact can it have when it's making decisions based on data selection and previous data? Thank you.